Welcome back to the His Glassworks Cold Working Studio. Today we're going to be talking about our Flex-Tec Anti-Shatter Coating. And you may notice that I'm in a kind of different location than our videos are normally shot in. So our Flex-Tec material is very susceptible to humidity changes. So this is one of our more temperature controlled rooms. We do have an air conditioning unit in here that keeps the humidity at a regular level and the temperature at a regular level for the different things that we have to work with, like our Flex-Tec or our Hextol. So today we're going to be demonstrating our Flex-Tec in our kind of controlled environment room, which is why we're a little different here. So it's vitally important to remember that if you're going to use the Flex-Tec material, you need to have some sort of temperature and humidity controlled environment to do it in. If you do it in an environment with high humidity, you're going to have some very inconsistent results with your Flex-Tec. So it's very, very important to make sure you are in a humidity controlled environment when you're working with the Flex-Tec. The second thing we need to make sure about is the cleanliness of our glass material. Now, if you're bonding anything to a glass surface, be it the Flex-Tec, Hextol, or any other material, you need to make sure that your glass surface is really clean. If it's not clean, whatever you're trying to bond to the glass is going to bond to whatever's on the surface of the glass instead of the glass itself. So it's very important to make sure that these surfaces are extremely well cleaned before you try and use the Flex-Tec material. Now you can do this a number of different ways. You can use a reagent grade isopropyl alcohol, which is a 99% pure isopropyl alcohol, or acetone. Both of these things are solvents. So if you use those, they are going to dissolve anything that's on the surface of this glass. Now you need to be sure if you're going to use isopropyl alcohol or acetone to clean your glass, you want to do it multiple times. If you do it one single time, it's going to dissolve whatever's on the surface of your glass and you're just going to spread it around and make matters worse. Instead of using acetone or isopropyl alcohol to clean your glass before applying your Flex-Tec, my preferred method of cleaning the glass is using whiting. Whiting is basically calcium carbonate, a powder. It is a non-detergent cleaner. So you can scrub your glass with this with a little bit of water. It's going to take anything and everything off the surface of the glass, and it's not going to leave behind anything else on the glass. Other cleaners like window cleaners and things like that will have additives in there like surfactants that will actually leave something on the surface of the glass. You don't want that. You want something that's going to clean everything off the surface of your glass and not leave anything else behind. Whiting, calcium carbonate is a great non-detergent cleaner, so it's going to be the way I'm going to clean our glass today. So we'll go and do that right now. So we're outside with our bowl now, and I apologize if there's some ambient noise. We've got a lot of trucks and things going by the business park here. But I've got my whiting here, which is, like I said, a powdered calcium carbonate material. So I can put that pretty much anywhere in the bowl here. Just going to add some in here. And then I've got a bucket of water over here. Then I'm just going to put my hand in and grab some water. This is all deionized water and filter water, so it's not going to add anything to my glass. So once I add this, I'm going to get this into sort of a slurry and then start scrubbing away. While my bowl is drying from cleaning with the whiting, I'm going to go over the setup for using Flex-Tec. So Flex-Tec, once you mix the two parts, you've got about 13 minutes of working time with it. So it's a really tight working time from the time that you mix it, degas it, and then try and apply it. 13 minutes is enough to do fairly large surfaces without too much trouble, but you need to be prepared ahead of time so you're not scrambling for things. Obviously, you'll need your Flex-Tec, your part A and your part B. This is what you're going to measure out. So you'll need some cups both to measure your part A and your part B. So you want to measure those out ahead of time, and I'll tell you why in a minute. You'll want your third cup that you're actually going to mix your A and B into. Make sure it's going to be large enough to fit your A and B for whatever process and whatever project you have going on. So I've got that. You're going to want a stirring rod of some sort. This is a glass stirring rod, so I know I'm not going to introduce any random element into my chemistry, say be it from a metal pick that might have some oils or thing on the surface. I love glass stirring rods. They're the absolute best. So with our glass bowl, it's going to be outside, it's going to be in water. So in situations where you're going to use the Flex-Tec, then it's going to be in environments that are going to have high humidity, water, changes in temperature, those sort of things. We highly recommend using the A-1100 Amino-silane on your glass surfaces before you use your Flex-Tec. I'll go as far as to say it's a required element for your Flex-Tec. You do not want to use Flex-Tec without your A-1100 for the longevity of the Flex-Tec. So A-1100, you may be asking, what in the world is that? It's an amino-silane. So there are a lot of amino-silanes out there in the world. This one in particular is called A-1100. This amino-silane is formulated for helping epoxies bond to the silica in glass. So this is a very glass-specific amino-silane. It is made specifically for two-part mixture adhesives like Flex-Tec, like Hextol, like our XTR, to bond more readily to the silica in the glass. So this material, we sell it both as a concentrate and pre-mixed. You do not want to use it in concentrated form. You do want to mix this with a reagent grade isopropyl. We sell this pre-mixed for people to just go ahead and use, no problem. So the A-1100, what that will do is it will chemically alter the surface of the glass to more readily allow an epoxy to bond to the silica in the glass. Once you apply the A-1100 to the glass, it will permanently change the chemical composition of that glass. So you can either leave that A-1100 on the surface of the glass and go ahead and bond with your Flex-Tec or your Hextol or whatever you're going to bond with, or you can put the A-1100 on the glass, let it sit for 3 or 4 minutes, then clean your glass again and remove the A-1100 from the surface. Does not matter. It has done its job. It has permanently altered that chemical composition of the glass. You do not need to leave the A-1100 on the glass. You can clean that off the surface again without any trouble at all. Will not affect it. It will do its job. So I will say again, it's really a required element if you're going to use your Flex-Tec in any type of environment that's outdoors or in public spaces. Apply the A-1100 to your glass first. We will go over that. That's going to be our next step in prepping our glass for use with our Flex-Tec. So our 1100. I always have these blue shop towels around. They are lint-free. They're not going to leave any kind of debris on your surfaces. They're great for cleaning up things, wiping up overspills. I always have them on hand right next to where I'm working. Don't always use them, but I always have them. So this is our setup right here. Now I'll also be using a digital scale to mix my part A and my part B to get that accurate. And I also have a small vacuum pump system that we will show a little bit later to degas my mixed Flex-Tec. Okay, so we have cleaned our glass with our whiting. Our bowl has dried now, so our next step is to put the A-1100 Amino-silane on there. So when I'm working with any chemicals, I'm going to make sure to wear gloves to protect myself. These are just your standard nitrile gloves, nothing special there. You can buy these from just about anywhere. We also carry like calf length, shoulder length nitrile gloves. These are going to be fine for most things. I've got my blue lint-free paper towels. That's what I'm going to use with the A-1100 material. So we've got our A-1100 that we've spoken about earlier. It's an amino-silane that's going to allow the silica in the glass to bond more readily to any two-part epoxy material that you use, like our Flex-Tec. So this is simple. It's already pre-mixed in an isopropyl alcohol. I'm just going to take my A-1100, put a little bit on my paper towel, and start to apply it to my glass surface. You don't have to be super fast with it. You can take your time. The isopropyl alcohol will evaporate off and leave a nice film of the A-1100 onto the glass. So it's really quite easy to work with. You do want to make sure you get full coverage on all your glass. Try not to miss any spots, because that will be an area that then the Flex-Tec may not bond well to. So you want to make sure you get really good coverage on the entire surface that you're going to be bonding. You don't have to worry about wiping it off. Like I said, the isopropyl alcohol will evaporate off and leave this thin film of the A-1100 for you. Okay, so we're going to leave that for a few minutes to allow the isopropyl alcohol to evaporate off and for the A-1100 to do its job. While we're doing that, we're going to move over and measure out our part A and part B of Flex-Tec. Now remember when I talked about Flex-Tec being a little more susceptible to humidity? Well, part of that is we're going to measure out our part A and our part B into separate cups. And then we're going to put these cups into a little hot box that's about 80 degrees while we prep the rest of our material. That'll help any random moisture that has managed to come into our part A and part B to evaporate out and make sure that we do not have any extraneous moisture going on in there. Now Flex-Tec measures out to about 12 square feet per pound of material coverage wise. So I've done my calculations for that bowl and hopefully I've gotten pretty close, so I know what my part A and my part B need to be. So I'm going to put my part A cup onto my scale. I'm going to make sure I'm choosing my part A. And I'm going to measure out the amount that I needed for this mixture. Sorry about that, I was left-handed. Now Flex-Tec has measured out 13 parts of A to 20 parts of B. So you really are best off adding up what you need coverage-wise first, and figuring out what you need for your part A and your part B to get your correct mixture. And that's about right for my part A. I'm going to set my part A aside. Use my part B cup. Zero out my scale again just to make sure. And then I'm going to pour my part B. Now you can see probably from this that my part B is a thinner viscosity than my part A. So you have to be aware of that when you're pouring, not to go a little bit crazy because it will pour out a little bit faster. All right, now that I have those poured out, we're going to move these into a little hot box and let these sit at about 80 degrees while we prep our other materials. Now that we've coated our glass bowl surface with our A-1100 Amino-silane, we've let it sit on there for a little while. It's cured, it's chemically altered the surface of our glass for us. I'm going to take it back outside again. We're going to clean it with our calcium carbonate or our whiting again. We're going to get everything off the surface of the glass again. Remember, you don't have to leave the A-1100 on there. You can re-clean your glass. It has already changed the chemical composition of the glass, so you are good to go. I always like to re-clean it again just so it doesn't capture any smears or streaks or weird looking things underneath the coating that's left over from the A1100. It doesn't have to stay on there, so we're going to take it back outside, scrub it down with our whiting again, and clean it up before we try and coat with our Flex-Tec. So we've cleaned our bowl a second time. I've got my part A and my part B that are all pre-measured. They've been in our hot box at about 80 degrees for about 10 minutes or so. That's more than enough time to make sure there's any moisture that is evaporated out of that. I have my larger mixing cup that I'm going to mix my part A and part B in, and I have our small vacuum pump and vacuum chamber that I'm going to degas. So remember, once you start mixing, you have about 13 minutes to work with. So it's a good idea to have a timer. I'm going to make a little timer on my Apple Watch here. So when I start mixing these things, I'll start a 13-minute timer. It'll go into my degassing chamber. We'll degas it. Then we'll get our bowl up here and start to apply it. So I'm going to pour my part A into my larger bucket. It's a little bit thicker viscosity, so it's going to take a little bit longer for most of it to come out. So I'm always going to put part A in first. So now I'm going to pour my part B in. Get as much of that out as I can. And while 13 minutes doesn't seem like a very long time, it's actually quite a while, so you don't have to rush too much. Now as you're mixing, let's see if I can get a little closer. You can probably see it's a little cloudy. So you want to keep mixing this until it clears back up, and you can see the lines of the two epoxies mixing in there. the part A and part B. So you just want to keep mixing until that goes clear again. Now obviously the more material you have, the more you're going to have to mix and the more bubbles you create. So that means the more it's going to have to degas. You can already see it's starting to get clearer. You don't see those lines in it anymore. I'm going to go a little bit further just to make sure we have this mixed really well. Get into the corners of the cup. And that's pretty good. So now that I have that mixed, I'm going to add it to our vacuum chamber. So we've got a very simple little vacuum chamber here. We've got a small vacuum pump we bought from Amazon along with this little chamber, which is just a desiccating chamber. So started the vacuum on there, and you can probably see in a few minutes it'll start pulling bubbles. Now the vacuum chamber generally only takes a few minutes. You can see the bubbles rising to the surface and popping. You can let that run while you prep other things. Depending on if you really want a bubble free, you sometimes don't even have to degas it if you don't want to. So like I said before, anytime I'm working with chemicals, I'm going to use gloves. These again are just standard nitrile gloves, nothing special there. There's nothing terribly toxic or problematic with the Flex-Tec. It's just a good idea of anytime you're using any chemicals to make sure you're wearing some protection. It's not a bad idea to keep that up. So our Flex-Tec is degassed now and it's ready to go, and I probably have about 7 minutes left. Adding time for video setup eats in some of my time. The degassing really didn't take that long. But I have a foam brush that I'm going to use. Now, if you use a brush of any kind, foam or bristled, you're going to introduce bubbles into your Flex-Tec. With the surface this big and the time frame that I've got with the video, I'm going to go ahead and use the foam brush because it's just going to be easier. You could also pour this material and then rotate the bowl, or if you've got a flat piece, move the flat piece to get the Flex-Tec to go edge to edge on a piece. You can mask off edges with painter's tape to create a dam that makes it very easy. So you could take the bowl and kind of rotate it and let the Flex-Tec move to the edges and create a nice pure seam without any bubbles. For this, I'm going to go ahead and use the foam brush, which will introduce some bubbles into the mixture. So I'm going to start and just pour some, starting at the edges. I don't want to go over my outside edge. So I'm being very careful about how I pour it until I got to there. And you can see my Flex-Tec is moving into my bowl. Now I'm just going to use my foam brush to cover my areas. And the Flex-Tec will self-level, which is very nice, so you don't have to worry about the brush strokes so much. But like I said, it is going to introduce bubbles into the surface, so you will have some bubbled texture on the surface. Now that I've coated my bowl with our Flex-Tec, what I need to do is apply a little heat. So I have a heat lamp here that's going to go onto this. It's really a good step to try and put some heat onto your Flex-Tec surfaces for about 4 to 6 hours. It's going to help the material cure a little bit better and a little more evenly and get everything working the way it should. Again, it's mostly about trying to keep moisture away from the area while it's curing. The heat lamp is going to excite the chemical reaction so it goes a little bit faster. It's going to keep any moisture from building up on your surfaces, and overall just give you a much better, more consistent coating on your glass. So putting a heat lamp of some sort onto the material for a good 4 to 6 hours is a good way to make sure that this comes out correctly. So I coated this bowl yesterday. We left a heat lamp on it for about 6 hours or so, and then we let it cure overnight. Don't always have to do that, but it worked for our timing. We were able to coat this material, keep a heat lamp on it. At the end of our day, we shut it off and let it cure overnight. Now that we're in the next morning, you can tell our coating is nice and cured, it's done, it's not tacky. One drawback that I found out from doing this, remember we used a foam brush to apply our Flex-Tec to our bowl. If I were to try and do this bowl a second time, I think I would have done it a little bit differently. I would have probably put some tape around my edges to create a dam, and then put my Flex-Tec in here and gotten a couple of us to pick up this bowl and move it to try and move the material around inside the bowl. The reason being, anytime I use a brush, like the foam brush or a bristle brush, it's going to introduce bubbles into the Flex-Tec coating. Typically, that doesn't bother me a whole lot. They're not terribly noticeable. But on this curved surface, what happened was all my bubbles that were on the surface of my Flex-Tec material slowly made their way down into the bowl. And I'm going to show you what happened here. So we're going to take a look inside of our bowl now. And what happened was all the little bubbles that were on the edges in our bowl slowly flowed down into the bowl overnight, and all those bubbles collected into the bottom here in this little trough and created this white ring. Now this isn't white Flex-Tec, these are all just bubbles. These are tons and tons of bubbles in the Flex-Tec material that slowly came down the side overnight as this cured and pulled into the bottom here and ended up creating this white ring effect, which is just basically a conglomeration of bubbles. This is all cured and done. It's nice and hard, but it's just not clear. It's a little white ring. So if I were to do this again, I think I definitely would create a dam with tape along these edges and down in here, and then pour the Flex-Tec in here and rotate this bowl around to try and get full coverage with the bowl. So that way I wouldn't introduce any bubbles into this mixture. But this was a success anyway. Nice even coating on everything. It looks really good, should work really nicely, so turned out pretty well. With the Flex-Tec process you just watched, that's not the end-all be-all. It doesn't have to be exactly like that. Everybody's process is going to be a little bit different. As we talked about with cleaning your glass, you can use acetone or reagent-grade isopropyl. You can use the whiting that I'm much more fond of. Lots of different ways to clean your glass. Just do it, so you make sure that your glass surface is cleaned. Process-wise, you may not need to warm up your part A and part B if you don't want to. It's just something I do in my process to make sure I don't have any extra moisture in there that's going to affect the bond. The length of time you have heat on it. You can go without heat if you've got a very nice temperature and humidity controlled area. It'll probably do fine. Extra heat always helps. It'll help it cure a little bit faster. 6 hours, maybe, maybe not. 2 hours, put it on a timer. All these things are a little bit flexible. None of them are set in stone, and your process is going to dictate how it's going to work for you. So there are adjustments you can make. If it doesn't turn out quite right, maybe you need to go back and make some further adjustments. This is the process I found in our studio that works really well for using Flex-Tec. And I did promise that we would look at how Flex-Tec works. So this is a piece of glass, just a random piece of glass that I put a single coating of the Flex-Tec on. It's been on here for a couple of months. It's actually been in a bucket of water for about a month, just making sure it would stick in a harsh environment. This was used with the A-1100 Amino-silane, so it's got a single coating of the Flex-Tec on there. Let me see if I can move a little bit closer. So you may be able to see here. So you can't really tell the coatings on there for the most part. It's coated on this side. You may be able to see some bubbles from when I used my foam brush to apply the Flex-Tec. But it's got a single coating on this side of the glass. So we're going to put it down here on the table again, and we're going to break it and see what happens. Again, this is my piece. It's coated with Flex-Tec on this side. I'm going to go ahead and put this side down on our table, and I've got my handy hammer here, and let's see what happens. So that broke pretty nicely, but it didn't go flying across the room. Now, if this was a regular piece of glass and I had smacked that with the hammer, pieces would be flying all over the place. Big chunks, things would be flying up at my face. Safety glasses would be of no concern, but this is holding together nicely. And like I said, one single coat of the Flex-Tec on that side. Obviously, I'm a little bit floppy, of course, because I just pounded the mess out of that piece of glass, but it's all holding together. We've got some little pieces going here, but if I'd coated this both sides, I wouldn't even have these little pieces on the plastic. It would all be holding together. So again, you get a good idea of how the Flex-Tec works. It is not going to stop your glass from breaking. It's going to stop your glass from shattering and flying all over the place and probably injuring someone. It works really well with a single coat. You can double coat, do both sides of it. You can laminate Flex-Tec between two pieces of glass as a layer that will keep both pieces of those glass together if anything breaks. Highly versatile material that really helps keep your pieces safe from impact and possible injury. Thanks very much, and if you have any questions, feel free to give us a call, drop us an email. We're happy to answer them.